We're going to go ahead and get started. So, very important insights you're about to see. Of course, one of the topics preeminently that we've been discussing this weekend here at the Cosmic Summit 2024 has been the Younger Dryas and the various theories about what actually might have caused this abrupt cold reversal that happened, between maybe 12,007 to 12,900 years ago. Joining me here on stage are members of the Comet Research Group, a team of scientists, PhD professionals from various fields who have been contributing to our expanding knowledge of the idea that indeed perhaps some form of impact occurred and that this indeed could have been the primary factor driving the Younger Dryas mystery. And so I'd like to introduce those who are here on stage right now. To my immediate right, your left, we have Dallas Abbot. We also have Joanne Ballard, who you've heard from earlier this morning, who gave her lecture. Yesterday, you heard Dr. Randy Daniel present on Clovis lithics. And then also joining us, a friend and colleague of mine whose interests range far beyond just remote sensing and ancient cataclysms, Dr. Malcolm Le Compte down here. And we're going to be discussing the Comet Research Group and its efforts today. Oh, and of course, joining us remotely, I didn't forget about Marc Young, who all the way from Australia is piping in over here. Now, Marc also was with us live at the event last year. Here he is. Everybody's making their way to the stage right now. Marc Young, of course, gave an excellent presentation there in Asheville, North Carolina last year. Last but not least, Steve Collins also joins us, and I'm sure he's just been giving a talk too, so we're right back into the thick of it, aren't we here? I think everyone's already had bios, but I do want to go down the list and have each of you talk a little about who you are and what you do. And Steve, maybe especially for those who are in here listening to my talk, give us a bit of background on you and your research.
I think you're going to catch my breath. I've been in the archaeological world doing field work and writing and all that for the last, since the Iron Age, I think. And but my focus has always been on the Near East, even though we're now digging a Native American site for fieldwork purposes for my students. But I have focused a lot, and I'm kind of known for that. I get ribbed about it a lot, but I make no apologies about, I don't mind being called a biblical archaeologist, but I just happen to be an archaeologist. Amen. Yeah, I just happen to be an archaeologist who takes the Bible seriously as history for good reasons. I find no reasons not to. And so that puts me on the butt end of a few jokes. And but I've learned how to answer those people. They always, like Bill Deaver and others, with the big dogs in the field. He'll see me at ACER, he'll wave that, "Hey, Steve, you still looking for Abraham?" And of course, I have to say, "Found him, Bill." Found him. So anyway, we put up with things like that. But I guess what I call myself, George will call me a person of faith, that sort of thing. Really, that's not it. It's not it. Faith is, the faith that I hold is a faith founded on fact. And I really style myself as an evidential factualist. And I just go where the evidence leads, and I'm fine being there. I don't care what anybody else thinks. Just give me the facts. And so that's what I do. Archaeology, I dig. Have trowel, will dig.
I love it. Dallas,
okay.
A bit of a background.
So my PhD is, I'm actually a marine geologist. My PhD is in marine geology with a minor in geophysics. And I started out working on submarine hydrothermal vents, then I got interested in the early Earth, and then I got interested in impacts. And I've done a lot of work, but impacts are really hard to prove. So, I've kind of just moved around and done various things, and I've had a lot of fun doing science. I wasn't very good at getting grants, and so actually the Madagascar work, for which you invited me, was funded by a Russian remote sensing company. Wow. And we went in the field with somebody who actually knew a lot about tsunami deposits, who was from Australia. Then we went with 2 seismology graduate students from Madagascar and a seismologist from Russia. So that's how it happened.
Fascinating.
Dallas, tell everyone your institution because it is so distinguished.
Oh, I'm a research scientist at Lamont Doherty Earth Observatory, which is part of Columbia.
That's one of the finest earth science laboratories on Earth.
Well, thank you. Yeah, our department was actually rated #1 in the country by U.S. News and World Report.
Yeah, that's a real institution and has been for more than 50
there's
years.
600 people who work at that site, and over 100 of them have PhDs.
Y'all know a lot about the planet up there.
Yeah, so it's a great place to work because, you go to lunch, you can find people. That's actually how I did ice core work too, and we found cosmic dust between 530 and 533 and 539 AD, and that work was made possible because I met somebody who worked on ice cores at lunch, and I told him how fascinated I was by this period of time, and he said, "I'll teach you how to work on ice cores."
Yeah. Joanne, please.
Hi, I'm Joanne Ballard, and my background is I have a PhD in geography and a master's in geology. My background is in paleoenvironments and biogeography, and so I'm very interested in late glacial processes. And I'm a catastrophist, so I'm very interested in cosmic impacts and anything, KT impact, things like that. And I'm currently associated with the Czech Academy of the Sciences as an advisor. I'm not actually in Czechoslovakia, but I enjoy working with them on late glacial papers and that kind of thing. And I'm also working at the U.S. Army Corps of Engineers currently.
Joanne, is it true that, do you agree that you were the first and perhaps still, unfortunately, the only person to pursue their PhD based on an interest in the Younger Dryas impact hypothesis?
I don't know if I'm the only one, but yes, that is why I did it. I was interested in the megafauna extinction, and then I had met Rick Firestone in 2005. He came out with his paper in 2007, and so that's when I went to graduate school, and I thought I wanted to be able to test this hypothesis or do something because it's so interesting, and so that's why I started
And
it.
you did.
Yep, and I did.
Excellent. Dr. Daniel?
Yeah. Good morning. Thank you for being here. Yeah, my name is Randy Daniel. I'm a professor of anthropology at East Carolina University, where I've been since 1996. I'm just an archaeologist, sort of a dirt archaeologist, but I'm interested in prehistoric hunter-gatherers and sort of the earliest presence of peoples here in North America, including Clovis folk, right? And that's where I came into the Younger Dryas part of this kind of indirectly. Of course, Younger Dryas is part of the time period, as I talked about yesterday, that is associated with the Clovis folk. And since archaeology is becoming increasingly interdisciplinary, right, I became interested in the Younger Dryas as a climate event associated with the Clovis folk and the debate around what was the cause of the Younger Dryas. And I became then part of the research associated with this through my then student Chris Moore, who has been a primary leader in investigating this. And Chris was a student of mine when we were digging along the Tar River. I mentioned some of that yesterday, where we've then found some proxies associated with the Younger Dryas. And I've been working with Chris and along these lines for, I don't know, 15 years or so.
Dr. Le Compte.
My background is actually in atmospheric physics. I've been called an astrophysicist. The department that gives you the degree, and the degree says astrophysics, planetary astrophysics, which means I'm a solar system astrophysicist, or a space scientist, if you will. And I became involved in remote sensing, satellite remote sensing primarily, and it began to dawn on me that the attributes of remote sensing systems that I was dealing with would be useful to establish the impact rates that the Earth was undergoing over time. And I did some early experiments of my own to determine if they were consistent with what was being presented in the journals of the time, and I found them to be elevated, that they were maybe an order of magnitude higher than what was estimated for the objects that we were dealing with. So that got me interested in impacts, and out of that, I got involved with the Comet Research Group through Dallas's efforts. She was the one who directed me kindly enough to meet with some of the real core members of the Comet Research Group, and I now work with Chris Moore, Randy's graduate student, who's been a real help in this effort. And I mainly work on the SEM and do a lot of SEM support work for sediment analysis, where we look for proxies for the impact events that we're on about. And that's been a lot of fun, and that's pretty much what I do, is provide the support to either archaeologists. If I'm on a site where I'm collecting soil samples, sometimes I can bring a GPR along and help them out with ground penetrating radar or satellite information. So I get a combination of remote sensing, the soil analysis, the space science that's involved in all these disciplines. I started off as an interdisciplinary scientist, so I pretty much have an open mind to almost anything.
You know the old crack about, well, it doesn't take a rocket scientist. Well, in the case of the Comet Research Group, somebody said early on, we need a rocket scientist. That's what Malcolm is. He's a rocket scientist.
That was my first degree.
Yeah.
You got one. Mark, all the way from Australia, can you give us a bit of a background on your work?
Yeah, hi. My name is Marc Young. I'm a PhD candidate at Flinders University in South Australia. I enrolled at uni in 2017 after seeing the JRE podcast with Graham and Randall to study the Younger Dryas. I've got a Bachelor of Archaeology in Environmental Science, and after graduating I joined the Comet Research Group and did a post-grad research project on the Younger Dryas magnetic microsurveillance. Today, my PhD research is studying the hydrodynamics of a desert lake system in the middle of Australia to enable prospecting of new early indigenous archaeological sites. And yeah, that's about it.
Excellent. As you can see, we have an interdisciplinary group here. Since we've got the microphone down on that end of the stage, Malcolm, I'd like to start with you, and I'll remind our panelists, of course, if you can, keep your responses fairly tight. I want to try and get to some questions from those in the audience if you have them too, but I'm going to lead off with the first round. Malcolm, in terms of the combined efforts of the Comet Research Group, could you give us just a quick explanation of really what it is the group is aiming to do when you combine all of these different fields and professions? What is it that you hope to try and achieve?
Well, what I'd like to see is a characterization of the event itself. Right now, I think we're pretty much adrift. We really don't have a good characterization of what actually happened at 12/8. We know that something happened and it was pretty catastrophic and pretty widespread. We have indicators that are just almost teasing clues as to how bad it was, and we have all these proxies in the soil. It's kind of like the pursuit of the KPG event before they found the crater. We don't know if there's a crater. We know that there's a lot of material in the soil that is anomalous, that shouldn't be there unless it's an impact event or an extraterrestrial impact event. And characterizing that, I think, is the key thrust of the efforts of the Comet Research Group.
Really briefly also, Malcolm, when you describe the KP event, for anyone who may not be familiar with the Alvarez team and what they discovered, where we have a known impact event, and of course what is found in that boundary layer, can you discuss what that is and why it's significant to the work that the team does?
Well, what pushed the Alvarez hypothesis that there was a big event at the KPG boundary 65 million years ago, which became the so-called dinosaur killer. That was the iridium in a layer that was found pretty much across the world, or a good bit of the world, and we look for similar things, these proxies for the for the material that would have been deposited by a major event. Our event appears to be very different from theirs in many ways, but we have found a layer of PGEs. Chris Moore has really done a good job of characterizing that. It's a layer of platinum, so the platinum group elements start with platinum, osmium, and iridium are the three ones that we look for that are not common in the Earth's crust. Deeper down you can find them, but in the Earth's crust they're very rare. But if an ET object comes in, it's usually laced with that stuff, and it gets spread across the landscape during the event. What else can I say? We have other proxies, of course, that we look for, and melt glass is a key one. We haven't found that many sites with the melt glass, because the melt glass is heavier, tends to fall more quickly, so you've got to be pretty near the epicenter to find melt glass. We found maybe half a dozen sites that produce melt glass. And melt glass is also considered to be one of the major proxies to indicate an extraterrestrial event occurred. The microspherules, of course, are spread all over the landscape. They're much smaller, more easy to be dispersed into the environment by high winds, which are pretty typical of the Younger Dryas boundary, the episode where it starts the Younger Dryas cooling. When we have that, and prior to that, we have very high winds, which we believe sculpt the landscape in certain ways that you can't see today. You can't, in my view, you cannot compare a feature on the Earth's surface today to one that was, to ephemeral features, for example, that may have existed back at the time of the Pleistocene, because the conditions are so dramatically different. We're talking not cyclonic, but tropical storm force winds are average. That's your average day is a tropical storm force wind going across the landscape that's almost devoid of vegetation. So we're looking at the environment that might mimic that is the top of a mountain when you see Krumholtz, these stunted pines, things like that. That's sort of the landscape that you might have during the Younger Dryas.
I think that's a good summary right there. Yeah. Randy,
can I ask, shock quartz, can I ask a question?
Please, please.
The shock quartz is a new proxy, right? Is that,
yes.
Can you describe some of that, please?
Yeah, the shock quartz that we've found is not true shock quartz. The shock quartz that we've found is not true shock quartz, what they call a PDF. The quartz is fractured and shocked, but what it has that distinguishes it from regular shattered quartz is that it's into the crevices of the lamellae or the fissures that are occurring in these quartz is amorphous silica, which takes of the order of anywhere from 1,700 to melt to 2,200 for vaporization, which is what we think happened. And this stuff was injected into the cracks. It's a well-established, in terms of the literature, it's well established that this stuff has been occurred and studied in association with impacts. You find it at the nuclear bomb detonation sites. You find it at the meteor crater in Arizona. If you go far enough afield, you'll find this what we call shock fractured quartz, and it's filled with this amorphous silica that is the result of the high temperatures. So it's a combination of pressure and temperature process that produces this what we call shock fractured quartz. So that's what we're seeing, and the evidence is pretty dramatic that we see at many of the sites. We should see, what's bothering me at the moment is that we should be seeing melt glass more frequently than we're seeing, and I don't quite understand why we're not.
Does that relate to the substrate? Because in the Netherlands, I did find it, but that's sand. It's covered sand.
Yeah, that's undoubtedly true. So it's a process that we've just really gotten into. It's a new proxy, and we're really just produced, I think, 3 papers in the last few months on findings at different sites and the implications, not to mention the initial paper that likened it to the Trinity event, the Russian detonations. We're finding the same kind of material there and at the other sites. And above and below this one layer at the YDB, you don't see it. It's really located at that layer.
Excellent summary indeed. Joanne, maybe the point that you were asking him about, could you extrapolate a little bit on that, please, the substrates, before we come back to Dr. Daniel?
So Malcolm was just saying that they're not seeing as much melt glass as they would expect, and I said that it may depend on the substrate because my sites in the Netherlands are cover sands, and so the melt glass I found, well, the sand is quartz, and so, you know, if you don't have enough quartz grains around in the sediment, maybe you won't see that.
Indeed, yeah. So you would need that indigenous presence. And so some of those outliers could be as a result of the lack of the presence, in other words, in those respective areas. You talked a lot about proxies in your lecture this morning. Could you discuss how we analyze those proxies, what that means, and what that relevance is to the study of these phenomena, what might have contributed to this event so long ago?
So we look at different things in lake sediments, which is my specialty, and then within the lake sediments, I was looking at charcoal for evidence for fire and siliceous aggregates for evidence for fire, but we can also look for diatoms, for sponge spicules, you can look at the geochemistry to try and get an idea of what's going on as far as an event or a change. You can look at pollen. The pollen is going to tell you about vegetational changes, which is very important if you have a dramatic catastrophic event. I mean, it could happen over a period of time if it's a slow onset drought or something like that, but a catastrophe for sure, you're going to see changes in the pollen around a pond. And so I think Dallas can speak more about diatoms and that kind of thing.
Please, yeah, Dallas, can you weigh in?
Well, I did some ice core work, and we've first of all, we did find cosmic dust, which was recorded in ancient, between 533 and 539 AD. And in ancient historical records, they talk about the stars twinkling anomalously during that time, and that had been interpreted by Mike Bailey as cosmic dust. But we were the first people who actually found physical evidence that there was more cosmic dust falling down onto the Earth at that time. But in addition, we found a lot of volcanic ash, and 3 of the layers of volcanic ash, we had 21 for a 10-year time period, were accompanied by marine diatoms and other siliceous marine organisms. And when I got diatom experts to look at it, some of them were diatoms. Diatoms tend to be fairly cosmopolitan, but there are some species that are very definitely tropical, and we found tropical diatoms.
When you're talking about that, just for the layman maybe who isn't familiar with that term, can you describe what those diatoms are, what they represent?
They're siliceous microorganisms, and you have both terrestrial and marine diatoms, but they look different. And also, the marine, we found enough of them. In one layer, we found like 55, and if they're marine, they tend to have more of the round diatoms, and there are other diatoms that are very long and skinny, and so the proportion of round diatoms also fit with a marine organism, a marine origin for the diatoms.
Indeed.
So, but we think these were from an explosive volcanic eruption, but the same, if there is an oceanic crater out there associated with either Younger Dryas and or the Carolina Bays, there should be in an ice core marine diatoms that would give you some clue as to where the crater might be. And also, if there were airbursts associated in the Younger Dryas, sounds to me like there were a lot of airbursts, there should be some ammonium anomalies in the ice cores. Because you can see Tunguska, not in every ice core, but in the GISP2 ice core, they had a nice detailed record of ammonium. And Tunguska shows up as a pronounced ammonium anomaly. And then if you look at southern hemisphere ice cores, there was a Brazilian Tunguska in the 1930s. That shows up also as a pronounced ammonium anomaly. And I went and I found out from a collaborator that apparently there was supposed to have been an airburst in Hopewell time. And so I looked at the GISP2 ice core. There's 3 pretty big ammonium anomalies. So somebody should look at those to see, because there's evidence from the Hopewell site that there was a big airburst. And one of those anomalies presumably dates the Hopewell airburst. And with ice cores, you can get dates that are good to within, in that time period, plus or minus 2 years.
Wow, that's an excellent overview. Well, since we've got the mic on this end here, Steve, I want to come over to you for a moment. And Dallas said something that just fascinated me, the idea that there were ancient accounts of anomalous twinkling or scintillation of stars, which might describe phenomena that were occurring at that time. Now, again, we obviously have similar implications when it comes to historical or biblical archaeology, because we have accounts that could point to archaeological realities. Now, within the context of this kind of research, could you maybe build on that idea a little bit, please?
Yes. I kind of got pulled into this whole thing, sort of backwards, not really kicking
And Steve, I'll save you the trouble just so we're not confused. Steve is technically not a member of the Comet Research Group.
No.
Though he's intimately in the tank with
They
him.
won't leave me alone.
Yeah, and that's true for Dallas as well, but only because, she's got another group, and she's welcome anytime, but we need not, brand her with that as well. Now, these three, they're already in trouble. Okay.
Yeah. Go ahead, Steve.
You don't have to look at study archaeology of the Near East very long before you realize that the paradigms, ideas, and interpretive frameworks of what most archaeologists think about the history of the ancient Near East hasn't changed in over 100 years. Very little is new. So in that community of scholars, whenever you even say the word catastrophe or anything like that, they just don't know how to process it. They're so stuck on their traditional paradigms. And so when we started looking at because when we found our site, we were triangulating around all the geodata that would take us from the biblical text as a map to Sodom. And that's how we found the site. And then a colleague of mine, Dr. John Moore, said to me one day, he said, doesn't Genesis 19:28, doesn't that sound like an airburst event to you? And my response was, what's an airburst event? At that point in time, I had no idea what that even was. So he starts sending me all the literature about Tunguska and all these things, and I'm thinking, it sounds like a phenomenological, fire, burning stone and fire out of the heavens. Does that kind of sound interesting? And I thought, you know what? Yeah, okay. So in our first probe, and this goes all the way back to 2005, the first time we cracked into the Middle Bronze Age destruction matrix at Tal El Hammam, we found what we lovingly called trinitite. Pulled that piece out, that melt glass on a surface of a piece of pottery, and looked at that, and I had no clue what it was, and I tossed it up to the guy that caught it up on the top said, "Oh, this looks like trinitite." And I said, "What's that?" And he happened to work for the Manhattan Project, was an old guy by then in his 80s, and he said, "Well, don't you hate it when people do that?" "No, I don't know." That stuff that was, the melted material at the
Alamogordo glass
at the base of the explosion of the first atomic bomb. Okay. I said, "Well, mark it and we'll analyze it." And so we did. And we took it down to New Mexico Tech, had it sliced and diced, and run through the good old Kamika 100. And what was funny about that was Dr. David Burley had sawn off the pieces to put in the machine, and I had the other bigger piece, about the size of the palm of your hand. And so I walked in, and Dr. Nelia Dunbar is at the machine, and she takes it out of my hand. And the first thing out of her mouth was, "Oh, nice piece of trinitite. Where did you get it?" And I said, "Never mind, just do the test." And no, I didn't say. She had on the lab sheet, where it was from and all that. But I didn't want to call it trinitite, but that's what everybody else was calling it, so the name kind of stuck. No, we don't have trinitite at Tal El-Hammam, but we do have something that is materially identical. And has the carbon separation, the calcium separation out. And I mean, we have pieces of trinitite at our lab, and they're identical. I mean, you can look at them upside down, sideways, and you can't tell the difference. Well, my point is that if this stuff was rare at Tal El-Hammam, what chance of us hitting a beautiful big piece of it on the very first probe? Let me tell you, here's what it looks like. There are over 13,000 6 by 6 meter squares on our site grid. And in the very first one of those that penetrated into the Middle Bronze Age, we had that beautiful piece of melt glass. That tells me statistically it's not rare. There's no way with that many squares we would have hit that, and we continue to find it, not just melted pottery, melted bricks. And by the way, there was another piece of pottery found. It's a neck of a jar. You can see the rounded part of the neck of the jar. One side of it is bubbled up into glass, melted. As you move around the side of it, the melt disappears and the normal pottery reappears. What does that tell you? It came from one direction. It was an heat exposure from one direction. So, I mean, these things just keep adding up and adding up and adding up. And so the Comet Research Group got involved.
I've been unintentionally rude there, because some people like to keep certain distance for various good reasons from Comet Research Group. And I was thinking Steve had corrected me in the past that he's not a member, to whatever that means, but he was correcting me in the past that he was not on the Comet Research Group paper on Tal El-Hammam, and kept his distance from that. Malcolm's telling me that he's now leading another paper. So as a director of the Comet Research Group, if you will accept it, I now officially anoint you a member of the Comet Research Group, which you can't avoid anyway, the way the thing works. Now you're on the team and you're full of shit and all that.
Yeah. There you go. Let's take the microphone, pass it down to Dr. Daniel there, because again, as Steve was kind of illustrating for us, there can be historical accounts, or those which actually maybe come from earlier oral traditions, and we can find some archaeological, and in this case, I don't know, would you call trinitite a geological? Technically, I guess we could call it that, but it's essentially something that's very strongly indicative of an airburst, like what it sounded like to you and what was brought to your attention. We also hear all these world traditions involving floods and things along those lines, and one can't help but speculate about whether there were events in the ancient past that oral traditions have carried forward, and we do have some data that can support that. But now, in terms of archaeology, Dr. Daniel, what does the archaeology, especially about this region, indicate to you? What can you determine based on the study of archaeology? What does it say about the conditions that might have been occurring around 12,800 years ago? And, how does that correlate with the predominant theories about the YDH?
Sure. We have, of course, no written accounts such as Steve is talking about. So all we have is the material record, right? The archaeological remains are a material record. The issue here is that there is no I think the archaeological record is kind of a code. There's no self-evident meaning in the archaeological record. All statements about the past are inferences, right? You have to draw some conclusion from that data. So archaeology is an increasingly interdisciplinary field, and so we have the archaeological record, which consists of the stones, the bones, all the artifacts, the features, but it also consists of the dirt itself, right? Dirt now is beginning to tell us a lot about the archaeological record. We're not only asking but answering questions that I could not conceive of when I was a student decades ago. We're getting Neanderthal DNA from dirt in caves in Europe, right? So why can't we get Younger Dryas impact signatures from dirt as well, right? These impact signatures. So the issue to me is, and again, I'm not the astrophysicist, I'm not the rocket science, so we're looking for these proxies. And so these proxies in many ways are like the archaeological record. There's no self-evident signatures in there as of yet. There's no smoking gun, right? So, but to me, the combination of several of these proxies that tend to correlate at this 13,000-year marker, that's beginning to be compelling evidence to me as this is a good working hypothesis, right? And so we're using this, and as all good science, we're trying to disprove it, right? You've got the hypothesis out there, and the way you proceed is you try to disprove it, right? You can't ever prove it, you try to disprove it. And so we're looking for ways to falsify it, and as yet, I know there's critics out there, and okay, that's good, that's the way we work, but to me, the best, most parsimonious explanation is now that these proxies are beginning to add up. Now, then their impact on, to your question here, Micah, sorry, is that what is the impact on the people? I'm interested in the people, right? If this is an impact event, that's one of these rare things that happen, right? And so that's going to have, somebody's going to have a bad day, right? Like at Tel Aviv, right? They had a bad day there, right? So, but what was the nature of that bad day? We're beginning to try to look at that. One idea, of course, is the nature of a possible population decline, right? And so, but again, we're trying to figure out how to measure population archaeologically, right? And so these are, it's all a fast-paced, ever-changing, methodologically needed research to drive to continue to address those questions.
Yeah, very all-encompassing. Mark, well, I'm sorry, actually.
Just a quick.
Yeah, Malcolm's got a quick follow-up, then Mark, we're coming over to you. Go ahead, Malcolm.
To me, when I got into this, one of the earliest digs I attended was getting samples from Al Goodyear's site at Topper. And Al had an experiment he wanted me to run, and it was to take samples from above the debitage from the flint napping that was going on at the Topper quarry. Topper was one of these industrial factories for producing, if I'm saying this correct?
Well, as close to an industrial factory as you could get 13,000 years ago. So
yeah.
A source of stone to make the toolkits that Clovis folk used.
So we took portions of the blades that were under manufacture at the time of the event, where we had dated this layer was known, partly because there was nothing above it, but we looked at the soil above these flakes of debit, these large flakes at coincident level with the flakes, and then below the flakes, in the shadow of the flakes. What we found were we had very few above, virtually none above, virtually none below, and these proxies were showing up at that level. So, and these proxies, by the way, just as an afterthought for what Steve was saying, is that these are the same proxies we see at Tel El Imam. We just looked for the same things and we found them. So that was basically our proof or validation of the hypothesis that it was an airburst.
Right. Tying all this together for us, Mark, you get the great challenge of having to bring it all together now. But again, as you sort of addressed last year for those attendees at the Cosmic Summit, can you tell us a little bit about how all of this data fits together in an emerging picture of a cataclysmic event long ago, and this being essentially the crux of the entire impact hypothesis?
Yeah, so there's this concept in impact science, I guess, called a spherical layer. And there's dozens of spherical layers that have been identified in the past. Many of them have no associated crater, yet the presence of a spherical layer is enough to conclusively identify that an impact happened at that time, right? So what we see at the Younger Dryas boundary is essentially a spherical layer. We have more impact proxies at the Younger Dryas boundary than most other spherical layers have. And quite frankly, the fact that it's not recognized as a spherical layer currently is a scientific crime, I guess. There's not many other ways to put it. The leading expert who actually coined or invented the concept of a spherical layer agrees that the Younger Dryas boundary should be called a spherical layer. So that's how it all fits together. One layer with everything in it, nothing above or below. So, yep.
So essentially, we have now kind of addressed, at least from a bird's eye perspective, all of the aspects, and there's far too much to get into comprehensively, but we have seen that there's an abundance of data, proxy information, and other information that is really pointing to this idea of a cataclysmic event that seems to be consistent with what we would expect from an impact. We've only got a couple of minutes and we're right on time. I'd love to keep us on schedule here, but do we have any final closing thoughts that anyone here on the panel would like to add? Just in closing, we've got maybe 2 minutes.
Whenever I mention these kinds of things that we're talking about here in my archaeological community, they look at you like you have carrots growing out of your ears. So it's always very nice to be able to talk about these things and say these things within a community of scientists and scholars who know about these things enough to talk about them and who are actually researching them, and actually be able to have a dialogue and be listened to and not looked at like you're some kind of nutcase. So thank you.
Very, very well said. Well, I would like to thank again our panelists, Steve Collins, Dallas Abbot, Joanne Ballard, Randy Daniel, Malcolm Le Compte, and Marc Young. Many here present members of the Comet Research Group, and again, I hope everyone feels far more educated on this enigmatic mystery of the past. Thank you all.
Thanks, everyone.
What was it? You got a question? Grab that microphone. Right behind you. We've got time for a couple of questions.
Are we looking at a bad day or a couple of bad days? And is Clovis culture showing up after this hypothesized impact, day or days?
Clovis ends, the onset of the Younger Dryas sort of marks the end of Clovis, right? So the Clovis culture, yeah. So Clovis has been pretty well radiocarbon dated, as I mentioned yesterday, from about 13,050 to about 12,900, right? 12,800, and so that.
Well, there's like 12,900 and then there's 11,700. There's kind of like.
Yeah, well, the Younger Dryas is at about 1,100 year period, right? Yeah. So it's 1,100 year period as part of that cold snap, as I refer to it, that occurs at the end of the last ice age.
What I mean by a bad day or bad days, it's like a shotgun shot versus a shotgun slug. You get the same kinetic energy, but sometimes you're looking at a bunch of little pieces.
Right. So, well, it looks like based on the sites, several continents, right, that some of these impact proxies are appearing at that date. So it's a fairly widespread event, but we have to, we don't know yet the full impact of this. I mean, you can make some reasoned assumptions that it impacted, remember we have the megafauna going extinction, and one of the ideas is that the megafauna were a victim of this as well. But we got to separate I'll call it the fact of the impact from its consequences. We still have to kind of sort out that.
What I'm getting is you might not find a giant crater, but just many little.
Oh yeah, that's one of the, right.
Very possible. Or of course, if there are air bursts, there may not be any singular crater at all, but it still could have had biomass burning effects. Yeah, go ahead, Malcolm.
Yeah, it could be ephemeral craters, but this is also key to the whole idea of a strategy to deflect. If you you have a strategy that says, well, we want to break them up into shotgun pellets to birdshot instead of a big rock, they can be every bit as devastating for the very reason that we're seeing it at the Younger Dryas, because it could be that that's what really kicked the climate into this state, was the fact that it was a shotgun and not a slug. And
that would get the whole side of the planet.
yeah, and you got that dust. You've got something akin to a nuclear winter you're dealing with instead of, so you could collapse the ecosystem, and that would really be devastating.
And again, we're looking at almost an 1100-year after effects. So, I mean, it was a bad day and a really bad, millennium after that. So let's jump one more question there, actually. I think we got time for at least a couple more here. Go ahead.
I wanted to touch on, Malcolm mentioned that the melt glass doesn't travel as far. What are some of the locations that you do find concentrations?
Orange County, New York is a place that's very famous for buried mastodons.
Okay.
We found a kill site in southern New York, in Orange County, near Middletown, New York, and that has melt glass. And there's one in Blackville.
Hiscock. Does it have it?
I'm not sure. Hiscock may have it.
Melrose, Abu Huraira, there's a couple more.
Oh, thanks.
Newtonville.
I was looking for your voice. Thank you. Mark saved me there. I couldn't remember all the list.
Provenance for the ammonia anomaly as well, is that burning biomatter?
Dallas?
Yeah, conventionally, ammonium anomalies have been considered to be from forest fires, but they're also from impacts. I mean, both Tunguska and the Brazilian Tunguska, it was in a forest area, so there was burning associated with it. But
We see that signal in the ice cores.
yeah, but we also see the signal. It looks like we see the signal at the time of the Hopewell event, which has been proven to be an impact. And the ammonium anomalies are not very common, and so I think what you could say is that they're probably. Impact is a better explanation for a lot of them than forest fires. Maybe a few of them are forest fires, but I haven't found any that were.
Interesting. Mark, can you tell us what we're looking at right there?
Certainly. So here we have a graph of the ammonium in the just to ice core that coincides with the platinum anomaly. And then down here we have other biomass burning aerosols, acetate, oxalate, and fulminate, and things like that, all at the elevated at the Young Dryas boundary. So yeah, these things do show up in the ice cores. There's pretty abundant evidence of it, so.
Well, there's your data. That's pretty impressive, isn't it? Sir, go ahead, please.
Following up more on the shotgun blast, with the availability of TEM and SEMs now, a lot of the early research showed that there were micro impacts into debitage and materials at sites, where actually arrowheads in Canada and things like that were hit with nanodiamonds, were hit with the micro impactors.
I recall some of that. It's hard to find.
It's hard to find. I didn't know if there's any more. I know Firestone talked about it some earlier, but some of that research out of Canada had some of those micro impactors that were found on one side of an object, not on the back side, where they were actually impacted at high speeds. And I didn't know if any more research has come out of that in the last few years with the more availability of SEMs and TEMs to do research.
We've occasionally looked at it, but it's something that we've actually moved on.
I understand. I didn't know if there's any.
Reports is so much better than Alclass.
Right.
The PGEs, the laser ablation studies that
Right.
you're doing, all of that is moving us much further than
Right.
the incidental apocryphal stories.
I didn't know if any more of that showed up into the effects that you're getting into now. Thank you.
Yeah, a lot of that evidence is very cool, but it's also very hard to prove.
Right.
So tend to stick with the proxy evidence.
Understand. Thank you.
Let's get to this last question here really quickly, please, if we can. Go ahead.
Thank you. I'm not a scientist. My profession is I'm a trial attorney, and I deal with scientists, scientific evidence, forensic analysts all the time as part of my profession. And don't get mad at me, but I'm about to make a generalization, and it deals quite specifically with what I've seen here and what Dr. Collins just said. I have found that scientists can be some of the most intolerant, biased, backstabbing, savage professionals that I've ever seen, especially when you deal with things like, if you say the word biblical, as you have pointed out, and I'm sure you've got lots of other stories of other professionals attacking you for that, or catastrophe theories. I hate the word conspiracy theories or catastrophe theories because it sounds like it doesn't deal with evidence, and that's what my profession is. How do you, as the Comet Research Group, how do you deal with the backlash that you undoubtedly have gotten and will continue to get from your other colleagues?
There's safety in numbers, and so that's why we have this group, so we can band together and be supportive of each other, and also be proactive in reaching out if there is a really negative review or something. We can address that, such as Martin Sweatman has addressed some of the scathing remarks from Holliday and others, and he's written rebuttals. So we've got people like Marc Young that are always on the lookout for what's new and on the coming up as far as critique of us, so that we can be proactive and address it and write and support our point of view, or give a counterpoint to the negativity, because I've been at conferences where Holliday was there and he was telling everybody that, oh, this has been disproven. And I thought, well, no, it hasn't. What about that platinum in the ice cores? And so people were snickering because he said that, and then when I spoke up, they're like, oh. So if I hadn't spoke up, people would have just, oh, he's like an important archaeologist, we should listen to him. Well, no, now somebody else has said something, so it balances things out. So I would say as a group, that helps us give strength and keep tabs on what's going on and be fair about things.
Science through analysis and through data, maybe, rather than by proclamation. Science does not occur through proclamation or opinion.
They may be few and far between, but there are, in reference to your statement, there are still some scientists out there who do have the ability to think critically and to look at situations and claims and process through them without bias. I said in my talk, but I'm going to repeat it because I think it's important. We sent thousands of bones from our Middle Bronze Age palace, at, we believe, the time of our airburst event, to the top expert in the world and his team on bones. They analyzed virtually everybody's bones from the Near East. He called me a few weeks ago and he said, sit down. He just said, sit down. And so I did. And he said, we've been looking at these bones for a long time now. And we know cooking bones. We know bones burned in fires. We know burns from Pompeii. We know burns from, fricasseeing chicken fried steak. We know everything, how to burn a bone, how to cook a bone, everything there is. We are the experts. And me, he said, I and my entire team have looked at these, and it's not just a few bones. All the bones from the Middle Bronze Age palace destruction at Tal Hammam have been subjected to burning or a heat in some way that we have no experience with. We have never seen anything like this. And they all said that. We don't know what it is yet, but he said, I read the paper and I get it.
Wow. I think we're just about done. If we have any concluding thoughts, really quickly, go ahead.
One final thing here. So it occurs to me as we're talking about the critics and the proponents of this, here's an idea. We need to get the various groups, representatives from the pro and con side here, get them in the same room. Let's try and work out what both sides might accept as evidence of this, and then independently both sides come together with a process that they would both recognize is trying to at least provisionally reconcile this so we can minimize this back and forth that we see in the literature and kind of proceed in a better fashion. You know, maybe NSF or somebody could come up with the bucks to do this. I'm just talking off the top of my head here, but meanwhile, we're just going to have this sort of back and forth until we get some reconciliation with respect to what counts as indicators of some kind of impact in the archaeological record.
So I'd just like to make a comment on that. There have been discussions on Facebook. Mark's been involved in these, and Chris Cottrell and others. And so whenever we've had these discussions, those archaeologists that are against the Younger Dryas impact hypothesis, they will just block you. So if you say something you don't like, they just block you, and you're invisible to them, and they can continue to pontificate and that kind of thing. So that's been my experience. But yes, that's a good idea. Ideally, that would happen.
Wow.
Ideally, it would happen, but if you think about what's happened with plate tectonics, basically the people who were against it, they died. There were few, maybe 10% of the people changed their minds, and the rest just kept their old opinions, and they would not be swayed.
So Dallas, you're saying that science advances one funeral at a time?
In some ways, yes.
Indeed, that can be, that can happen indeed. But you know, again, this is, I think, is the nature of paradigm shifts. If we read Thomas Kuhn, you know, the great philosopher of science, and how we see attitudes change over time only once you kind of get to a breaking point. Let's hope it doesn't have to be a cataclysmic one. But again, I do want to thank all of the panelists today for being very forward-thinking. Excellent questions also from our audience. Thank all of you guys for the questions. Really good stuff too. A very enlightening discussion. Thank you.